Give or take a couple of Planck times, the universe is nearly a second old, and still a very strange place. But matter has won the battle with antimatter. And now, it's time to build the universe. It's still extremely hot and expanding incredibly fast.
When the universe was a second old, the particles in it were very different than the particles we see today. There were no atoms. Nothing that we recognize in the room around us today yet existed.
Now, all that begins to change. Temperatures continue to cool. And as the primitive particles keep slowing down, they start bonding together to form the atoms of the first elements. The first one to form is hydrogen. Then, over the next 3 minutes, the universe begins to create 2 more elements, helium and lithium.
We went from a universe that was infinitely small to a universe that was light years in size. In the first 3 minutes, essentially everything interesting that was going to happen in the universe happened.
Well, not quite. If you were there, you couldn't see it.
When we look at the night sky, we can see literally billions of years into the past, and we think it's always been that way. Nope, not true. 380,000 years after the Big Bang, that's when the universe began to become transparent. But before then, it was milky.
There is a milky soup of loose electrons. The young universe has to cool down enough for the electrons to slow down and stick to new atoms. It took a long time for all of the hydrogen, helium, and lithium atoms in the universe to form. Scientists calculate it took 380,000 years for the electrons to slow down enough so that the universe could start mass-producing atoms. When that happens, the milky fog clears. The first light escapes and races across the universe. Nearly 14 billion years later, 2 young scientists in New Jersey pick it up by accident. In 1964, Arno Penzias and Robert Wilson were mapping radio signals across our galaxy. Everywhere they looked, they picked up a strange background hum. They first suspected their equipment. Maybe pigeon droppings on the antenna were causing the strange signal. But after cleaning the antenna, the mysterious hum remained. So much for pigeon droppings.
Penzias delivered a talk at Princeton University. And according to lore, one person in the back said, either you have discovered the effects of bird droppings or the creation of the universe.
It was, in fact, the moment of creation, nearly 14 billion years ago, when those first atoms got their electrons. That's the moment when the Milky Cloud clears and the new universe comes into view for the first time. To capture better images of this critical event, NASA launched the Cosmic Background Explorer satellite, or COBE. They pointed it out into space where it took the temperature of the universe. By measuring differences in temperature across space, they created the first map of our early universe. The images were called the face of God.
We got gorgeous pictures, baby pictures of the infant universe when it was 380,000 years of age. But there were problems with it. The picture was very fuzzy. The COBE results were simply not good enough.
So NASA launched an even more advanced satellite, WMAP, the Wilkinson Microwave Anisotropy Probe. In 2001, David Spergel was part of the team looking for a clearer image of the early universe.
It was exciting to go to the Cape. It was one of these moments where we're sitting there watching this. I was there with my family, watching the rocket go off. It was very exciting when within about a day, we were able to get our first signal from the satellite and know it was working and working properly.
This is the most detailed picture of the early universe ever taken, just 380,000 years after the Big Bang. The red and yellow areas are warmer, the blue and green regions cooler, and those temperature differences are clues to the future structure of the universe.
We see tiny variations in temperature. Those tiny variations in temperature reflect small variations in density. This region has more matter, this region has less matter.
Like a blueprint for the construction of our universe, this image shows us where there's more matter and where there's less. Regions with no matter will become empty space. Areas with denser matter will become the construction sites of galaxies, stars, and planets.
These are the fluctuations that will grow to form galaxies. So if it wasn't for those little density fluctuations, you and I would not be here today.
Our universe is now 380,000 years old and trillions of miles across. Clouds of hydrogen and helium gas float through space. It will take another 200 million years before those gases create the first stars.
These first stars ignited the universe into what must have been the most amazing fireworks. The universe went from the Dark Ages to an age of splendor when the first stars illuminated the gas and the universe began to glow in majestic fashion. I wish I'd been there.
It was like Christmas tree lights turning on. The universe began to light up in all directions until you formed the beautiful mosaic we now see today.
More and more stars turn on. 1 billion years after the Big Bang, the first galaxy forms. Over the next 8 billion years, countless more take shape. Then, about 5 billion years ago, in a quiet corner of one of those galaxies, gravity begins to draw in dust and gas. Gradually, they clump together and give birth to a star, our sun. 9 billion years after the Big Bang, our tiny solar system springs to life, and with it, planet Earth. Everything there is exists because of the Big Bang, and it's still going on. Our universe is still expanding. But it won't just keep going forever. Our universe had a beginning, and it will also have an end. In the 14 billion years since the Big Bang, galaxies have been created, filled with stars, planets, and moons. And the universe has been expanding the whole time.
We've learned space is quite big, at least 150 billion light years across.
The universe may be infinite. It might literally go on forever.
The answer is there doesn't have to be anything. In principle, the universe could be infinite and there's no outside. Or it could be closed on itself. It could be such that if I looked far enough in that direction, I'd see the back of my head.
We may never know if the Big Bang produced a universe that goes on forever. But we do know that the Big Bang hasn't stopped yet.
The Big Bang is really continuing now. We're continuing to bang, if you want, in the sense that the expansion of the universe is continuing.
One of the most astounding discoveries in the last few years has been the realization that our universe is not slowing down like we once thought, but it's actually speeding up. It's accelerating. It's in a runaway mode. We now believe there's something called dark energy, the energy of nothing that is pushing the galaxies apart and is killing the universe.
We can't see this destructive force, and we have no idea why it exists. But it could mean the end of everything created in the Big Bang. If dark energy continues pushing the universe apart, our Milky Way galaxy could become a lonely outpost. 100 billion years from now, most of our galactic neighbors will be out of sight. Stars will burn out, galaxies will grow dark, even atoms will tear apart. The birth of the universe, the Big Bang, was over in a flash, but the death of our universe will take almost forever.
That great philosopher of the Western world, Woody Allen, once said, "Eternity is an awful long time, especially toward the end."
Figuring out how our universe will end is as dark a mystery as the Big Bang. It could collapse back in on itself, like a balloon when the air is let out.
So would the universe end with a big crunch, a reverse of the Big Bang, or was it end by expanding out and becoming cold and dark? If you wish, would it end in fire or ice, or with a bang or a whimper?
If the universe collapses, it might trigger another Big Bang. Maybe that's already happened. And we're just one in a long line of universes.
Personally, I believe in continual genesis. That is, there's a never-ending process whereby universes collide, split apart, give birth to new universes, perhaps with the different laws of physics within each universe.
Maybe this isn't the first time it's happened. Maybe it's cyclic and it goes round and round again. Eventually we'll collapse and the whole thing will start over again.
One universe or many, they all start with a Big Bang.
Everything that makes us human, the atoms in our bodies, the jewelry we wear, all the things that lead to the tragedy of life and the beauty and the excitement, love, everything else, arose because of processes that happened 14 billion years ago. And if we really want to understand ourselves at some fundamental level, we really have to understand the Big Bang.
14 billion years ago, the Big Bang created time and space, our whole vast universe and everything in it, including us.
Some people ask the question, what's in it for me? The Big Bang gave us everything we see around us. The distribution of galaxies and stars. It set into motion the creation of elements that we see in the universe, and even the laws of physics themselves, we think, were born at the instant of creation.
Everything started with the Big Bang. One brief moment in time, 14 billion years ago, that contains the answers to our greatest questions about our past, our present, and our future. Each discovery brings us one step closer to understanding how the universe works.